In this video, we're going to talk about box and whisker plots and also about the 5-number summary. So the first thing we're going to talk about are the different parts of a box and whisker plot. A box and whisker plot is a display of data that divides a set of data into 4 parts. So this word should be familiar. The median or the middle is also called the second quartile or second quarter of the data. It separates the data into 2 halves, the numbers that are below the median and the numbers that are above the median. So when we're talking about the lower half, meaning the smaller numbers, we have a first quartile or the first quarter of the data. And when we talk about the upper half of the data, we talk about the third quartile. Now, sometimes you might see the first quartile written as the lower quartile, and you might see the third written as the upper quartile. These mean the same thing, it's just different ways to say it. And then the last part is the interquartile range. Is the difference between the first quartile and the third quartile. So Q3 minus Q1. So these vocab words are really important for our 5-number summary. Our 5-number summary includes the minimum of the data, the first quartile, the median, the third quartile, and the maximum. Those are the 5 numbers that make up our 5-number summary. So when we're going to do our 5-number summary, the first thing we need to always make sure is that our numbers are written in increasing order, meaning small to big. And the first thing we have to do is find the median. So again, that's our middle of our data. After we find the middle, then we can find the first and third quartile because those will be the middles of the middle. We'll talk about that in a second. Then you find the interquartile range, which is again your Q3 minus your Q1. So let's give this a try. In this set of data, I'm going to first check to make sure all the numbers are written in increasing order, which they are. So then I'm going to find my median. So right now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So 6 would be halfway. So 1, 2, 3, 4, 5, 6. Draw my line here. 1, 2, 3, 4, 5, 6. Now, when your median doesn't fall in an exact number, my median falls between 63 and 69. So to find the median, we average the 2 numbers that are in the middle. So I'm going to do 63 plus 69 and then divide it by 2. So my median is going to be 66. So now to find my upper quartile, well, that is, again, that's the same as the third quartile. I'm going to find the middle of this upper half. So my upper half has 6 numbers. So again, halfway would be 3. So again, I'm going to have to average those 2 numbers. So 72 plus 82 divided by 2. So my upper quartile is going to be 77. My lower quartile, or again, that's the same as the first quartile, that's the middle of the lower part of the numbers. So again, I'm going to find the halfway point. Well, halfway between 31 and 31 is 31. So that one's pretty easy. Now the last thing I need to do is find my interquartile range, which again is my upper quartile minus my lower quartile. So my upper was 77, my lower was 31. So my interquartile range is 46. Go ahead and try example 2. Pause the video. When you're ready to check your answers, hit play. Now for example 2, they gave us a dot plot, except for it's with X's instead of dots. So the first thing I need to do is write all my numbers in number order. After I write the numbers in number order, I'm going to find the middle. And so my median was 60. Then after that, I'm going to find the middle of my upper and the middle of my lower. and I have to average again with those. So I got 65 and 35. So my interquartile range was 30. So another part about box and whisker plots is being able to identify an outlier of a set of data. So an outlier of a set of data is a value that lies outside, is much smaller or much larger than the most values of the data. The range, which we should also know this vocab, is a set of data that's the difference between the highest and the lowest number. So the interquartile range is, again, the range between the quartiles. Your range in general is basically your max minus your min. So we have a little formula that helps us find the outliers. And this is really important for us to know. So when I'm trying to find the upper range, I'm going to do whatever my upper quartile is plus 1.5 times my interquartile range. And then when I'm trying to find the range for my lower, I'm going to do lower quartile minus 1.5 to the interquartile range. What this is going to do is it's going to give me two numbers. It's going to give me an upper range and a lower range. And anything that lies outside of that range is going to be considered an outlier. All right, so let's give this a try. So with the set of data, they want us to find the median, upper quartile, lower quartile, interquartile range again. So first thing I have to do is put these numbers in order. So I'm going to tell you how to do that just to save some time. So it's going to go 20, 25, 34, 37, 40, 46, 47, 57, 57, 69, 107. Okay. So now I need to find the middle of the data. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So that means my middle will be the sixth number. So 1, 2, 3, 4, 5, 6. And I have 5 numbers on each side. So my median is 46. Now, we haven't done an example like this before, but when you're finding your upper and lower quartile, you're going to include 46 for both sides. So when I'm finding the middle of the upper, it's going to be right here between 57 and 57, so 57. And when I find the middle of the lower, it's going to be between 34 and 37. So 34 plus 37 divided by 2 is going to give me 35.5. So my interquartile range is going to be 57 minus 35.5, so 21.5. All right, so now I need to determine the outliers. So I'm going to use the formulas that I highlighted up here. So I'm going to do my upper quartile. Let's try that again. Upper quartile minus or plus 1.5 times my inner quartile range. And I'm also going to do my lower quartile minus 1.5 times my inner quartile range. So my upper quartile was 57, so 57 plus 1.5 times 21.5. And I'm going to get 89.25. I'm going to do the same thing for my lower quartile, so 35.5 minus 1.5 times 21.5. And I'm going to get 3.25. So now my range, the biggest any number can be without being an outlier is 89.25, and the smallest it can be is 3.25. So when I look at my set of data, any number that lies outside of that range is going to be an outlier. So in this case, my outlier is the 107. Go ahead and try example 4. It's a similar problem where you need to find the outliers. When you are ready, play the video and see how you do. So when you put the numbers in order and find our, well, in this case, 4-number summary, we found the median is 37.7, the upper quartile is 40.7, the lower quartile is 32.6, and the inner quartile range is 8.1. Then I use the formula to find the upper range and the lower range. For my upper range, I got 52.85, and my lower range, I got 20.45. So any of my numbers in my set of data that are above or below that are going to be considered an outlier. So in this case, my outlier was 20. So the reason we learn about how to find all these numbers is all these numbers help us graph our box and whisker plots. So that's what we're going to talk about next. So we've already been practicing finding our 5-number summary. And so that's the first step really to finding a box or creating a box and whisker plot. So just like with a 5-number summary, really we've already learned how to do steps 1 through 4. Write the numbers in increasing order, find the median, determine the first and third quartile, determine if there's any outliers. The next part is basically just taking that data and turning it into a box and whisker plot. So let's first find our summary. So I'm going to put my numbers in increasing order. And again, I'm just going to tell you what it is because I know that you guys can put numbers in increasing order. So 5, 7, 9, 11, 11, 12, 16, 17, 19, 25, 28, 34. Okay, so now I want to find, just like above, I want to find the median. I want to find my upper quartile. I want to find my lower quartile. And I want to find my inner quartile range. I also want to think about what's my min and what's my max, because that'll help me when I graph. All right, so my median, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So again, my middle is going to be after 6. So 1, 2, 3, 4, 5, 6. So halfway between 12 and 16. So 12 plus 16 divided by 2 is 14. My upper quartile is going to be between 19 and 25, which will be 22. My lower quartile is going to be between 9 and 11, which would be 10. And my inner quartile range is going to be 22 minus 10, so it's going to be 12. My min of my data is 5, and the max of my data is 34. Assuming that there aren't any outliers, this may change. Because of an outlier, if there's an outlier for the set of data, then your minimum or maximum is going to change to the next number. So to make sure that I don't have any outliers, I'm going to find my upper range, which is my upper quartile, plus 1.5 times my inner quartile range, which was 12. So my upper is 40. My lower range is going to be 10 minus 1.5 times 12, and I'm actually going to get negative 8. I don't have any data that lies outside of that, so I have no outliers. All right, so now here comes the new part. Now I need to draw a number line. Oh, I already drew one for you. I'm so nice. Then I need to take the 5-number summary, and I'm going to put them basically on my graph. So now I need to think about a scale. My minimum's at 5, my maximum's at 34. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. So I could go by 5s, but if I go by 5s, I'm going to go 0 to 65, and that's too much. If I go by 2s, that's only going to give me to 26. So I guess I'm going to go by 3s. So I'm going to start with 3 here. And you don't have to start with 0. But I'm going to start with 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 39. Okay. So now I'm going to draw a box which extends from the first to the third quartile. So my first or my lower quartile is at 10. So I'm going to plot that roughly just a little bit more than 9. So there's my first quartile. My upper quartile or my third quartile is 22. So again, it's going to be a little past 21. And I'm going to draw a box, because that basically shows the majority of my data is going to lie between 10 and 22. But now I need to draw a line where the median is. So my median, also sometimes called my second quartile, remember that. is at 14, so that's going to be roughly right there. Then, so that's the box part of a box and whisker plot. The whiskers are where my max and min lie, and those are just going to be points. So my minimum's at 5, so that'd be roughly right about there. My maximum's at 34, which would be roughly right about there. So then I connect my box to my whiskers. So a box and whiskers plot basically illustrates how our data is distributed. You can see that the majority of our data is the 50% of our data actually is between 10 and 22. And then keeping in mind with a box and whisker plot that 25% of the data lies in each quarter. So 25% of the data lies from the minimum to the first quarter, from the first to the second, second, third to max. So now I'd like you to practice with these box and whisker plots. You have quite a few examples to go through. Example 2, and then example 3 where they gave you some data rather than just a list of numbers. We're going to do some interpreting farther down about how to read a box and whisker plot. And then one of the most important things I want to make sure that you go through is how to make a box and whisker plot on your graphing calculator. And there's some really good directions here that show you how to do it on a TI 83 or 84. I know it says 84, but it also works for an 83. So if you're having any trouble with any of this, make sure you come talk to me and I will help you because it's really important to be really good at box and whisker plots.